Hey everybody, just want to walk you through the exponent rules one more time so you have an actual event of examples of what to do with each one of these exponent rules as we go through them for your quizzes today. Alright, so starting out, I have an example at 5 to the third. So the 5 right here, this would be your base, and the 3 would be the exponents, or sometimes you might see it called power. So what that tells you is how many times you're going to multiply the base times itself. So since it's 5 to the third, that means we're going to multiply 5 times itself, 3 times. So 5 times 5 times 5. And we would get 125. So the only time we really want to care about that last part is if it actually says solve or evaluate. Alright, so otherwise, we're going to be leaving things in exponential form. So this thing right here is your exponential form. Alright, so our first rule that we talked about with exponents was product of powers. So all these rules can only be applied if the bases are the same. So what I have here is I have x to the n power times x to the n power. So bases are the same, so the base stays as x, so the base stays the same. And now, because I can do a shortcut, is I know what I can do is I can take my exponents and I can just add them. Alright, so an example of this, so let's use 5 to the 4th times 5 to the 6th. My bases are the same, so I keep my base the same, and all I have to do is add these two exponents together to get 5 to the nth power. Alright, so that is a simplified version. We've simplified that. Now you can do multiple things. So if I have a to the third times b to the third times a to the fourth times b to the fifth, I only apply my rule to things that go together. So a with a, b with b. Alright, so still apply my rule right here. So a, keep the base the same. Two exponents, 3 and 4. So that would be a to the 7th. Do the same thing with my b's. And that would be times b to the 8th power. Alright? And that would be the simplified form of that. So that's product of powers. That's when you're multiplying two bases together that are the same. Alright, the next one, we have power to a power. So that's that in parentheses, out parentheses. So in out parentheses, what I can do with my shortcut is base stays the same, and I can multiply my m times n. Alright, so what this would look like, if I have 5 to the 4th to the 3rd power, I got that in and out. Base would stay as 5. And then I would do 3 times 4, which would give me 12. So that would simplify to 5 to the 12th power. Let's look at one a little bit more complex. So 8 to the 3rd, b to the 2nd is the 4th power. Alright, so same thing I have inside and I have outside. So I have to take everything individually. So I have to do the 4 and the 3. So that would be a to the 12th. But then I also have to do the other parts, and that would be b to the 8th. So you're multiplying the outside exponent by each individual inside exponents to get your simplified version. So that's power to power. You'll recognize that one with parentheses in, and something on the outside of parentheses. Alright, division of the same base. So you'll see I have the same base here, x and x. So the base stays the same. What I can do with my shortcut is I can take m minus n. So what that would look like, if I had 8 to the 4th divided by 8 to the 3rd, my shortcuts would have, base stays as 8, and do 4 minus 3, which would give me 1, or I could just leave that as 8, because 8 to the first is just 8. If I had letters or variables, let's go with c to the 7th divided by c to the 3rd. Base stays as c, 7 minus 3 will give me 4. So that would be a simplified version of that. Alright. Power 0. Anything 0 power is always going to be 1. So it doesn't matter what it is. If I have 3, 5, 0, 0, 0, 0 to 0 power, it's still going to be 1. If I have negative 8 to the 0 power, it's still going to be 1. Now this one's going to be 1 because that negative's inside that parentheses. Now if you see this, that's going to be negative 1 because what your calculator, what it does, is it sees you doing 6 to 0, which is 1, but then it tacks that negative sign back on. All right, so if it's in parentheses, I keep it there. All right, so always 1. And our last one, negative exponents. So these are tricky, folks. Remember, there's 2 steps. So step 1 is we pretend the negative's not there and we just do the problem. So for example, in this first one, x to the negative 8, I pretend it's not there, and it would be x to the 8th. Step 2 is I make it that fraction. All right, so step 1, ignore the negative. All righty, and do problem. And because it is the negative exponent, that's where we have to do the flip, the fraction part. So flip the fraction. So how that would look with numbers. So 8 to the negative 2. I ignore the negative, so I'm not paying attention to it, so I would do 8 squared. Well, 8 squared is 64. And now because of this negative and the exponent, that's where I flip the fraction and get 1 over 64. All right, 4 to the negative 3rd. Once again, ignore the negatives. Just so happens that this one also happens to be 64 when I do 4 to the 3rd. And because of that negative, that creates 1 over the 64. All right? So your exponent rules, you got power products, power to power, 0 power, division the same base, as well as negative exponents. All right? So look and see what situations you have. Maybe you have a combo situation. Maybe there's more than one rule happening. So, break down, look and see, what does this look like? Does this look like one of the examples in your booklet? And go from there. All right? Have a great weekend, everybody.